All right, we can get started. It's 10 a.m. Good morning, everybody, and welcome to Kundinger Presents. Today, we're going to be talking about manufacturing's next chapter, the digital transformation. I'm your host, Brian Kundinger, and in a few minutes, or a few moments, we'll be joined via pre-recorded presentation by Mike Farian, who unfortunately couldn't be here today, who is the CTO of Advantech's IIoT Solutions, followed by a live presentation by Nathan Smith, who is the Director of Channel Sales for Advantech North America. All participants have been placed on mute. If you should have any questions at any time during the presentation, please use the chat function within the application control panel. We'll be monitoring the chat and we'll answer the questions as they come in. We've also allowed for Q&A time at the end of the session. After today's presentation, if you should have further questions or want to discuss any other Advantech or Kundinger solutions, please reach out to your regular Kundinger contact or email our general inbox at sales@kundinger.com. As always, you can always call us toll-free at 1-800-242-4811. Today's session is being recorded and will be available on our Kundinger Inc. YouTube channel for future review or to share with any colleagues. Just search for Kundinger Inc. on YouTube to find the channel and access this presentation as well as previous Kundinger Presents presentations. Now let me welcome Mike Farian, who will walk us through what digital transformation is and how it works.
The megatrend of OT-IT convergence is ushering digital transformation into the world of operations, using technology not only to eliminate waste and redundancy, but also to increase resilience, enabling companies to quickly adapt to rapidly changing conditions. I'm Mike Farian, CTO of Advantech's IoT Solutions Group. Today's agenda will introduce you to the concepts of digital transformation as they apply to manufacturing operations. We're surrounded by examples of digital transformation in the world of consumer electronics and enterprise. Think about the payments industry, retail, media, and entertainment. Companies who lead in digital transformation now dominate their industries. Digital transformation is using the combination of technology, data, process, and organization improvements in order to eliminate waste. Digital transformed businesses are flexible and resilient. They're able to adapt to rapidly changing conditions. And importantly, digitally transformed organizations can adapt to new technologies quickly without expensive refresh or rip and replace cycles. There's core rules that must be followed to be successful in digital transformation projects. We build only with open architectures. Legacy dedicated appliances drive high costs and they drive vendor lock-in, limiting your access to technology and solutions. Solutions must be edge-driven. Edge devices must be able to independently serve meaningful information into a unified database shared across all applications. We must be lightweight. No legacy automation polling protocols, and no data dumping. Edge devices need the intelligence to serve only meaningful semantic data that can then be used by any number of applications. And we always decouple. Never directly connect an application directly to an asset. Applications should consume their data from a shared database. Here are things you'll see in an operations environment that are operating in legacy modes. Employees will be using Excel to make decisions. Email is a part of workflows, both for communications and for transporting documents. Printers will be busy printing documents that were used in processes that date back to pre-computer age. Managers will be looking at reports filled with data about what happened yesterday or last month or last quarter in order to make the decisions. And the ERP system is dictating processes. It's not acting as a tool, but it's an obstacle to continuous improvement. Successful digital transformation will eliminate these legacy practices. Let's dive deeper into manufacturing. This is what a manufacturing business looks like, whether it's Excel and QuickBooks or millions of dollars of specialized software. And once all these pieces are in place, it's ongoing increases in material, labor, energy costs, manufacturers must continuously increase efficiency in order to compete. So they add things like OEE, and they often increase machine productivity maybe by 2 to 3x. Then they further upgrade their machines to be faster and better. But eventually they hit limits and diminishing returns. And you'll find that while improving efficiency, they've also been constraining themselves to be less and less adaptable and less flexible, unable to rapidly respond to changing environments. So let's take a look at this model when we apply the rules of digital transformation with a view towards manufacturing 4.0 type environments. We reduce friction throughout the business. We enable every person or process to access necessary data when and where they need it. You can swap in any module without causing major trauma to the rest of the business. We eliminate vendor dependencies and we reduce switching costs. This enables us to easily add new technologies that further increase productivity, efficiency, and capacity. So all that sounds great, but it's a lot to digest. So let's zoom in on the challenge specifically around machines. Now, this is the very messy industrial edge. It's dominantly brownfield equipment, which speaks from hundreds of different protocols with thousands of different data models. And some equipment has no communications at all. When integrating machines into a digitally transformed architecture, there are a number of approaches. Your newest machines, if you've avoided vendor-focused lock-in, you should be able to configure these to work under the rules of digital transformation in 4.0 directly. The brownfield machines with proprietary communications are going to require an edge intelligence layer, which will aggregate, filter, and publish contextual data up into that unified namespace. And then for machines with no communications, intelligent wired or wireless I/O modules can extract data on machine utilization, machine output, quality. And then for remote offsite machines and assets, intelligent LTE gateways can integrate them into your systems. I hope that gives you some insights into the world of digital transformation within industrial settings. Advantech has a large selection of open architecture, edge intelligence hardware platforms for edge compute, I/O, networking, and more that will enable your digital transformation Industry 4.0 projects. Thank you for watching.
Okay, so now we're going to pass the presentation over to Nathan Smith, who's going to walk us through the digital transformation at the edge.
Excuse me? You guys can't see it?
Yep, we can see your presentation, and you're on mute, so I took you off mute, so you should be good to go.
Oh, yeah. Okay. Well, thanks everybody for attending. And again, just to sort of follow up on what Mike Farron had just talked about. So digital transformation was more or less a concept of trying to pull various disparate devices and data together into one common database and then sharing from that database to a variety of different platforms above that. But one of the key parts of that is how do I get all this data into that common database or that unified database? And that involves a lot of things happening out at the edge. So Advantech has a lot of solutions that run at the edge, and this is really going to be the gist of this presentation, is talking about the various different edge devices Advantech has. So the first thing you might start out with is, what is the edge, right? So, you know, we hear a lot of talk about it, but what is the edge? And if I take a quote from Hunter S. Thompson, the edge, there's no honest way to explain it because only the people who really know where it is are the ones who have gone over it. But essentially, you know, the edge is everywhere. Everybody's got some access to it. It's sort of the terminology thing. We don't know it, but we're at the edge already. So the edge could consist of many different things. It can be an assembly cell. It could be some AGV moving around the plant floor. It could be a remote pumping station, some packaging lines, maybe some semicon machinery, even kiosk and remote devices. So those are the kind of things that we think about when we talk about at the edge. It's a process or a machine running right at the right where things happen on your plant floor. And it's looking like the edge intelligence marketplace is going to grow quite a bit over the next few years. And as you may recall, the buzz 3 years ago was all about going to the cloud, and everybody was talking about IoT, let's get data to the cloud. Well, as they started to implement some of this, they found out the costs are very high to get a cloud service going. There's latency issues, there's security issues. So there's a lot of different things that were going on in the cloud that were causing more problems than they were solving. And we were trying to pass all our data to the cloud. And we were running into time delays, network congestions, again, the data transmission costs. So the idea of edge computing is we'll get out to the edge, we'll do a lot of that data collection and manipulation at the edge. And if we do have to send things up into this unified database, it'll only be the relevant information, not all of it. And if we can take as many actions on the edge as we can, that's what we want to do. So what is happening at the edge? Well, we're collecting data, we're processing variables, we're doing some visualization out there, some remote monitoring of some assets. We're creating networks between different machines on the edge. And then finally, we are seeding information to the cloud, but we're not sending it all. We're just sending relevant information that maybe we pre-processed at the edge and sending the result up to the cloud. So what's different now than was years ago? Okay, so one of the big things that's different now is if you're familiar with virtualization in the old days, it was very expensive hardware, server level hardware that had a hypervisor or a VMware running on that application, on that server, and then every application you wanted to run on this hardware, this virtual machine, had to have its own operating system, and it got very expensive and for software and hardware wise. So what's really changed now and made this edge computing so much more viable and cost effective is the fact we moved to containers. So maybe some of you are familiar with Docker. Docker has a engine platform that runs in Linux on hardware, and it can run in very low-end hardware, you know, Atom type processors, nothing very big at all. And then I can have these containers set up within Docker, and each one of these containers can run its own application independently. I could run a database, I could run a visualization program, but each one runs in its own container, and then they will talk to each other through the Docker engines when they need to, and they can send data upstream when they need to. So what this allows you to do is to really compartmentalize your applications down at the edge for only the things you need. And what also is very good about the containers, they scale quite easily. So a lot of the software that goes into a container is it's essentially free software. It's unlicensed. And as you scale up and you need more software, that's when you might start running into the cost. You've decided, hey, I've now deployed 20 different edge applications out on my plant floor. I want to scale that up and start collecting data at a higher level. Well, I can take the same applications I'm running on the edge, scale that software up into more of a full-blown plant type system. And now I don't have to replicate and redo all my software because I can scale up from these containers. So then what happens in the, and what this then allows you to do is it lowers your overhead. I got faster boot up time on my machines. I'm isolated from other devices on the plant floor and even other applications within that container, within the Docker engine itself. So there's definitely some advantages over trying to do all this into the cloud. But what's running in these containers? So this is just a short list of the type of things that run in a container, but it gives you the idea of how you can build up a system right at the edge. So you can do some dashboarding with Grafana. So I can make some dashboards and see what's happening at the edge. Ignition now has some software that runs in containers. Iconics is going to be introducing software that runs in containers. Dynamic is a company we partner with that makes some gateway software. Its FogLamp is a gateway software that allows you to collect data and feed it into higher level SCADA systems when that needs to happen. Node-RED is a piece of software out there that can run in containers, and I can do dashboarding and messaging and some light programming there. Mosquito is an MQTT broker. A lot of people now want MQTT to communicate into cloud applications. TensorFlow is an AI image recognition software piece, and we have some edge devices that support that as well. And then we have a couple database applications, and there's many more out there. Just gives you an idea of of how many different programs are out there available to create your edge computing platforms, and they're all this open architecture. We're running on Linux platforms. We can run it on multiple different types of PCs, as we'll see throughout this presentations here. There's a lot of options to do this thing. So it makes it very easy and to implement, and a lot of open architecture, so I'm not tied into any one path that I have to follow to get the results I want. So that's what the container part about, and that's probably what makes the edge computing thing so viable these days, is this ability to do all these different things on a low-level platform running out at the edge. And so what is happening out there? So there's different things that we're doing at the edge. We're doing data collection at the edge. We're connecting to different devices at the edge. We can do some control at the edge. And then ultimately we're doing that compute at different levels of that data we've collected. And are we going to send that data up to the cloud, or are we going to process that data and maybe send it back to our devices at the edge because we've run the programs we needed to in this edge computing device, as opposed to going to the cloud and all the way back down again? So what does Advantech offer in this whole space? We offer devices that will do the data collect, we'll do the data connect, we can do data control, we can do the data compute, the data visualize, and the analyze. So we've got our Atom modules that can be wired or wireless devices that talk Modbus. We've got a range of wireless devices that'll talk Wi-Fi, LoRaWAN. Wizard Smart Mesh is becoming a popular technology to run on factory floors because of its redundant nature of communication. On the connect end of things, we've got a line of Ethernet switches that'll speak Modbus, Ethernet IP, Profinet, so now we can talk the protocols that these devices are talking on the plant floor and create networks that way. We have some things that do the control. We have various different compute platforms and different ways to visualize and analyze that data. And a lot of software packages that go along with these things to help make these things happen. So I'll just sort of touch on some of these a little more detail here. So on the data collect area, as I mentioned, up in the upper left there, we have our Wi-Fi modules. So if you wanted to go wirelessly, we could just connect to some inputs and then wirelessly back to the computing device we have on the floor. LoRaWAN is another technology that does wireless communication. That communicates back to a gateway, and that gateway can be your compute device, because I could run Python on that thing. I can put Node-RED on that device. So I can do different things right in that gateway before I send my data up into an on-premise SCADA system or even into the cloud. But I can do vibration analysis in here. I can read a lot of analogs and digital inputs into these devices. And then the Smart Mesh, Wizard Smart Mesh IP is this redundant type protocol network. And again, it's reading analog and digital inputs, comes back to a gateway. That gateway can talk Node-RED. It's got Python programming in it as well. And both of these have options to be cellular. So if I'm in a remote application, I can now send that data via cellular communication back to my SCADA system or wherever it needs to go. And then we have our traditional Atom modules, which talk Modbus, some talk Ethernet IP, some are serial, some are Modbus TCP. The idea is, though, here, these devices now allow you to collect that data from maybe machines that have no connection on them at all. There's no Ethernet plug, so how do you get the data out of them? We can use some of these devices. In a lot of instances, people don't want you to change their process or tap into what they're doing to collect this extra data. So we can piggyback on top of that existing control system. And these are quite easy to implement because obviously they're wireless. Many of these are battery operated. Some of these even have magnetic bases on them. So it's very easy to install these things. There's no installation costs involved, no wiring you have to deal with. So that makes it easy for us to now build up this data collection part of the edge computing world. And then if we get into the data connect part of it, so as I mentioned, we have a couple different solutions for data connect. We have our Modbus, Ethernet IP, or Profinet switches, so we can get onto Rockwell networks or Siemens networks or whatever devices are out there. PoE, a lot of things are happening with PoE devices at the edge now, whether it's cameras or security applications. We offer a line of PoE switches that do 15 watt, 30 watt, even up to 60 to 90 watt per port applications. And those are typically used for some security where you're controlling pan, tilt, zoom on cameras, that type of thing. And we have some ruggedized M12 connector switches. So if you actually are in a rugged environment out at the edge, which can be the case, there's some ruggedized connectivity for those options. And then as part of the whole data connect world, we have cellular modems. So here we have cellular routers on the left-hand side that are talking the 4G LTE. We talked the new Cat M1 technology out there, which is a very low bandwidth and low cost implementation of cellular. So it makes actually deploying a cellular network almost as inexpensive or sometimes cheaper than just doing straight up control, because at a couple bucks a month, I can collect all the data I want over my cellular network. And then we actually have devices that you can connect IO directly to, and they speak to the cellular networks. So there's quite a different options we have for connecting either within a plant or for remote applications. And then we offer software that helps you manage these devices. We have a VPN software for managing your routers. There's a network management software to keep track of all your switches on a plant floor and the devices they're communicating with. So a lot of options for solutions in this area. And then we look at the control part of the edge computing world. So Advantech has, we don't make a traditional PLC, we make more of the PAC controller, the programmable automation controller. So we have a PC running in the controller, and that PC will run Windows, and on that PC I can run these programs we talked about, the Linux applications. I can put containers on there and Node-RED. I can run code assist on these things. So that's where we do our control and talk EtherCAT. We have some other devices that allow you to do some control and use our Edgelink software, which I'll talk about in a little bit. But this is how we can do this edge computing and control at the same time, because our devices are computers that do control. So we have some flexibility in how we can deploy these devices as well. Then we get into the edge data compute environment, and this is where Advantech is really strong, and many of you know us probably primarily for these type of devices, but it's all our embedded computing solutions. Everywhere from a small Atom 6700 module you see there, which actually runs Linux. So that's a small embedded PC. And then they grow in performance and horsepower all the way up to our high-end i7 series processors. So depending what we're doing at the edge, I would select the right computer to load Docker on and put our edge software on. I can load our Edgelink software onto these devices. The Uno 420 is our outdoor class 1 div 2 version. So if you have any outdoor applications, that's a good device there. So that's definitely an edge type platform. And then if we look at what our Wisepass software actually is, so the Wisepass Edgelink software is a utility that Advantech provides that allows you to connect to the different protocols and devices out in the field, then aggregates that data. We can do some massaging of that data and then send that up into a SCADA system that's on premise. Maybe it's going off into the cloud. You have a lot of different options of where you can send that data. So I'm going to pause for a moment here, and I'm going to run a short video that gives you like a 2-minute video on what this Edgelink does. So let me power this up, and hopefully everything runs smoothly.
With the emergence of industrial IoT, it greatly lowers your cost to digitize and connect your assets. Nevertheless, connectivity is not enough. Your business IoT needs a brain, and here comes Wise Edgelink. It is aimed at edge application, serving as a hub for data acquisition, storage, transmission, and analysis. With it, you can monitor asset performance, receive alarm notifications, reduces the need for on-site maintenance. Wise Edgelink has plug-and-play functionality for data transmission to the cloud. The efficient interface eliminates complex programming and configuration. With just a few clicks, you can upload data for analysis and visualization. You don't need to worry about system integration and the potential for expansion. Wise Edgelink supports over 200 drivers and various protocols, with the functionality to integrate data with third-party systems. The software is composed by Edgelink Studio and Edgelink Runtime, with downlink data acquisition capabilities integrated with uplink connectivity and intelligence functions, enabling project configuration, device monitoring, data acquisition, and transmission. data log, and connectivity to the cloud and third-party systems. Using Advantech's gateway solutions, despite the diverse protocols and limited space for installation, you can realize Industry 4.0 in just one move. Edgelink supports uplinking with OPC, UA, MQTT, Modbus, IEC 104, TNP3, VACnet, and so on. It allows the possibility to use a single integrated platform for data acquisition, communication, and transmission. If you are planning to get smart, choose the smarter Edgelink.
Okay, so that's our Edgelink software. And if I get back to the presentation here, just a quick summary again of what that does. So it's not a visualization tool. It's just a way of collecting data. So I can go out and talk to my IO and collect that data. I can bring it into the PC that's running our Edgelink software and do pre-processing of that data. So maybe I can do some tag scaling, do some calculation on these tags. Again, so do I really need to send every bit of data up into my next system? No, not necessarily. So let's pre-process that right at the edge and then only send up into the SCADA systems or the cloud what I need to send up there. So we offer Edgelink on a couple different platforms. So it's depending what your application is and what you're trying to communicate with, we can get the right device for that. And then in the visualization world, Advantech offers a lot of devices that we can do visualization. Once I've collected my data and I want to look at some screens, whether I'm running some Ignition, some Iconic, some Wonder, whatever, or even our web access HMI software that Advantech offers. So we have some embedded PCs that'll run Linux and Android operating systems and just work as a web-based browser for looking at our screens. We have some tablet PCs that also can be used. Obviously, walking around the plant floor, maybe I want to use a tablet, running my software there. And then again, I mentioned our web access HMI. So our HMI software will run on various different platforms. We have all of these are of the smaller nature. We have big screens as well, but typically on the edge, maybe I don't have quite a big a screen. So these are in the 7-inch world. We have some as small as 4.3 inch. Of course, we can go up to as large as 23 inch if we need to. And then Thin Manager for people who are running Wonderware or some other software where they want to have a Thin Manager client on the plant floor. Some of these are also Thin Manager enabled. So that's the visualization part of it. And then this is a newer part that we're seeing more and more of out there is the analyzer part of it. So this is using the GPU technologies, and NVIDIA is a name we all know and are familiar with, and we have some embedded boards we've designed with NVIDIA that run on some of our edge platforms. Again, they're running these platforms, and everything we've been talking about are 24 volts, they're stainless steel, solid state drives inside them. So we're not worrying about moving parts or trying to bring 120 to them. And same with this family. And we're starting to see some of these get more implemented in a lot of vision applications. Actually, some of them going on robotic arms that they're doing high-speed pick and place. So if I'm running a GPU processor in there right at the edge, I can analyze that data right there at the robot and make actions rather than having to slow the process down by sending it upstream to be processed and having it come back down again. Most of the applications I think people see now with this GPU stuff and artificial intelligence is a lot of facial recognition and smart city applications for traffic lights and traffic monitoring, but it's becoming more common in industrial applications, particularly related to vision things, just because of its high-speed computing nature. So it can really increase some bandwidths. So that's what all the things Advantech does with computing on the edge. Obviously, if you know Advantech, we've got a whole lot more computers out there that do all sorts of different applications, high-end things. Just want to touch on the whole edge computing world because that tends to be where there seems to be a big growth going on and more people are implementing the digital transformation, which requires a lot of edge computing. Now, a couple examples we have of what we've done with this. So here's an example on a bottling line. We're right out at the edge doing this. On the line, we're collecting data with our wizard nodes, goes back to one of our gateways. It's running Node-RED. And so we've deployed a few of these applications running Node-RED. But as I mentioned before, Node-RED is one of these free pieces of software. And if I want to scale it up, Node-RED itself is probably not the most ideal program to scale up with. but it's a good proof of concept tool. So we can do a proof of concept out at the edge, determine that it's collecting us a lot of meaningful data. We could really see some cost savings here. And then I'll scale this up and maybe move from Node-RED into a different SCADA system that can handle looking at multiple lines at one time. So that's using our wireless wizard application. Another one is a baghouse filter system. So this is out there on the dust collectors, and in this particular application, we're again using the wizard node, and it's going through our gateway and communicating with an Allen Bradley PLC. But the idea here is in some of these baghouses where they're doing dust collection, they just automatically fire a charge, and it shakes the filters to drop all the dust they've collected down into the bags below to be carted away and removed. But they just do it automatically on a certain time, and the cost for doing that, the motors and everything involved, it gets quite expensive, and they're doing it without even knowing if they need to do it. So what we've now done with this baghouse filter system is we can monitor the pressure differential on either side of the filter, and when it reaches a certain level that we're monitoring with our wizard nodes, we can send a trigger back to the PLC that'll fire off the motor to shake the filter system. So that ended up over several different electric motors and baghouses they had, it ended up pretty good cost savings for them to reduce the amount of energy and effort required in that application. But again, this one was piloted and used Node-RED, and as they scale up, they could move to different SCADA systems. Here's another one using our tablets to move around the facility. So in this particular case, they're just monitoring the status of machines, and with this tablet, I can not only talk to our Wi-Fi devices we have on the floor collecting data, but there's other Bluetooth devices out here as well. So we're bringing that data in, and the customer in this particular application wrote their program in C++. And again, that's the advantage of having these open platforms. I'm in a Windows environment. I'll just write a program in C++ and do what I need to do. So this is what we're doing with the Wi-Fi and the tablet application. Here's one in a rolling steel plant doing vibration monitoring. Again, we're out at the edge monitoring a machine, collecting data on this, and we're only going to send back data again that's going to be tell you, hey, we're trending into an alarm zone or something, versus continually streaming data that is just telling you it's running fine. We only want to see data when there's an exception or something. So another application using our wizard nodes and gateways and vibration sensor. And this is an application, it's a stamping plant using a tier 1 automotive supplier. We're putting a vibration sensor on the upper right there. You'll see that's a vibration sensor. It's battery operated. It reads vibration and temperature at the actual device. That's connected to the LoRa gateway. In this particular application, we're talking LoRa WAN, not Wi-Fi or smart mesh. And then we also are bringing in some other signals that are not pure vibration, so we can connect those sensors to the square module on the left, which has analog and digital inputs, both feeding back to the gateway. And then that gateway is sending data into one of our small embedded PCs, the Uno, which is now running Linux and has Docker app on it, and we're running multiple different containers on that. One's Node-RED, one is the Influx database, one's the Grafana dashboard, and that now is presenting the data we want to see about what's happening with the vibration on this machine. So those are some of the applications we have running things at the edge and how we've implemented them. And you can see there's a lot of open architectures here, so it's very flexible how we implement these. And I think working with the folks at Kundinger, we can help you guys come up with, if there's a particular edge application you want to do, with Kundinger's application experience and some of our hardware and software solutions, we can help build an edge computing solution that can meet a lot of different requirements. So with that, I guess I'll kind of wrap it up and say, hey, we're open for some questions here. If anybody has any questions on anything we've talked about, feel free.
Absolutely. Thank you, Nathan. Are there any questions from any of the attendees today? No. Okay.
Does any of this stir any thoughts in your guys' minds? You see any applications out there where this might be useful for you? And if so, you don't want to talk about it now, reach out to the Brian and his team, and we'll be happy to discuss those applications. We have some of these things that we can do proof of concepts with. So if you think you want to try this out, we could probably get you a wizard node and a gateway and play around a little bit and see if it gives you guys meaningful data just as a proof of concept, as I mentioned. So keep that in mind.
Absolutely. Absolutely. Okay. Well, if there are no questions, that'll conclude today's Kundinger Presents. I did want to give a thank you to Mike Varian as well as Nathan Smith for the great information on digital transformation and the equipment and solutions that we have to offer to take people to the edge and beyond. As Nathan mentioned, if you did want to have further discussions on today's content or any of the other Kundinger and or Advantech solutions, please feel free to reach out to your regular Kundinger contact. Or as always, you can email us at sales@kundinger.com or call us toll free at 1-800-242-4811. I just wanted to add one other note out here. Please remember to follow us on LinkedIn to stay up to date on all of our other product solutions, as well as our future Kundinger Presents webinars. And we look forward to you joining us again on future Kundinger Presents. So at that, we will go ahead and leave it there. And I want to wish everybody a fantastic day, and even better weekend. Talk to everybody soon.
Thank you.